Hi Professor, my name is Alfredo Alvarez, and this is my presentation for Gaming 475. What we're seeing on the screen is the end result of my final project. From the feature list, I tried to implement as much as I could. Right now, lights work on objects, textures worked, and they load from files, and they come from a single graphics object. The camera pans, the camera moves up, and I'm going to try to demonstrate all of this. The way I decided to arrange it was just to put them in space in different positions with different settings so we could see what could be done with the engine. I have two cameras, one displaying the frustum and the other one just showing the environment so we can see it. So I'm going to start using the keyboard to move my camera forward, and then I'm going to move my camera backwards. You can see it moves sideways, moves up, it moves down. The way it's done, it's relative to the position that the camera is looking. So using the B direction, I pretty much orient the camera to follow something that makes sense. If I hit spacebar, I will be able to actually flip over and see the objects from a different position. So here we are inside all the objects, and we can see that we have wireframes working in terms of the renderers. We have textures without light. We have different objects. We have the torus, we have the sphere, we have the cube or boxes, we have wireframes. Basically what I was trying to do was a sample. If you look at the spheres on the right, we can see how the scale works and how it goes for everything. In here I try moving the lights so it would point to different places so we can see shadows in different places. Oh yeah, the camera pans, and it's done in my demo. It's done with F1, F2, F3, and F4. F1 will pan towards the left, and then F2 will do it towards the right. F3 will pan up, and F4 will pan down. So it's pretty useful to look around. So with the torus, what I did was I used my different rotations on them, and I also did with light and without light so we could see the difference between the two. So we're kind of really inside of the collection of objects. They're all floating around. I didn't add any extra textures from the ones in the class. I was just trying to go over the concepts. So in terms of the cooling, I implemented it, but I did not have time to do a really proper implementation. And my implementation right now, what it does is it just has a fixed size for the sphere, and that fixed size that which starts with like just one float gets expanded into into whatever the scale in X of the object it is. It's a complete hack, and it's not the proper way to do it, but I just wanted to get the cooling system working even if I couldn't get the bounding object working. I saw you posted a new way to do it that works, but it's pretty late, so I'm probably gonna bet. So just to show that everything outside of the frame is getting cooled, I'm gonna minimize the window and actually show the output from Visual Studio. So from that window that we were seeing there, it's generating this output, and those are the names of all the objects that are getting cooled because we can't see them. As we keep moving and we expand it, it will take them away from the view or put them in view. If we go to space, we can see what happened with the frustum and how we moved it off. what I did was that camera has a really small one, so we can actually see how those pieces interact. And then the other camera, the one that we're looking at right now, actually has a pretty big frustum, so we can actually see the entire scene. Let's see, what did I not talk about? I don't have any actual animations right now running. All I have are static objects. I kind of wanted to do, and I started playing with moving the camera around using the same methodology that you used for moving the spheres in the demos. And I got it like in a little prototype. I have something working, but it was not good enough that I could actually get it in because it was looking a little bit jittery. Let's see if anything else of interest. So what I'm gonna do now is I'm actually gonna change into another video to actually go into the classes, because this frame I might just make my Visual Studio a little bit smaller and talk a little bit about my structure. So basically this is my project here, and what I did is like I wanted to create originally a scene manager, and because I only have one scene, what I did is I just add a static method for the scene that's running, but the idea is that we can expand this into multiple scene if it was a game. From class I started with the camera managers and that kind of stuff. The interesting thing from the scene class is that it actually, if we look at the header, it's probably a little bit clearer, but it actually takes out each of the parts that we do, so when we move from one scene to another, you can actually really quickly change what you're doing. So that's pretty much the core where everything starts. In terms of the graphic objects, this is what I ended up with: the pyramid, sphere, torus, vertex rocks. Vertex rocks is just a collection of atoms that I needed for the way I do it. I created a model factory, which pretty much I use it to be able to detach the rest of the system from the knowledge that the models are different. The way right now my system works, it still uses the VVO implementation that we did in class, and it still works with the definition to be able to like either write or read. The system reads and it writes fine. The only thing is, like, when it writes, you actually have to input, because of the way write works, you actually have to input the number of vertices and the number of triangles. So let me show that 1 second. Basically this is what we have. So we got this model base object, which inherits from model, and this is the main class that loads all the models. These are the methods that I made: rotation, angle, x, y, set scale. So one of my models, if we look at it, look at model H. This is just the definition of the vertices and triangles. So it's it by itself. So if we look at the CPP file, all that you have is pretty much the list, and it just looks at a file with the definition of it. So this is pretty much what my shape classes have. It's just they create vertex definition method with the properties that they need. Like I said, depending on the setting that you have, it either write this down into the file system, or it will read the information. If you're reading and your information can be different than this, it'll just load whatever you put in the file. I didn't put a bunch of definitions to like not make this run just because I didn't want to like have to put in all those files. So that's pretty much what I got. I'm not sure exactly what else do we have to present, but this is what I got. I'm gonna be doing putting it YouTube and doing the final check-in in a few minutes. I just need to make a buddy build and make sure that everything works. Thanks for the class, and I will start trying to finish the final tomorrow and send it over. Thank you very much. Have a good one.